Okay, so we need to learn just the common way how we're going to write interval notation, and then we're going to talk about unions and intersections, which you need all this for. So, hey, we might as well get it so we're all on the same page. Okay, now interval notation we're going to do right here. Just so you know, this is called set notation. Okay, and if you've been Math 30 was always using set notation, and then the last couple of years in the diploma they just started using interval notation as well. So I always did some with my 30-1s, but now we're going to just go into a bit more detail on how to use these when you actually have to solve a problem, especially when you're doing inequalities, which is what this is all about. Okay, so just kind of like if you have an open circle, make sure that you're using curved brackets, right? Okay, and when it's filled in, because that means it also includes that point, we'll use the square. Okay, and again, that is 30-1 review, right? So you can see A and B, it is greater than A, but less than B. So all we do is write A, comma, B. Okay, as opposed to the next one that says, hey, let's include A and B. So we're going to use square brackets. In the next one, we'll have a square for A and a round for B. Next one would be the opposite, right? A is going to have round, B will have square brackets. Okay, A greater than A. Okay, so greater than A, we're going to take A and we're going to go to infinity. And we're going to use always round, or open brackets they're called. Okay, so maybe we should, I just want to go up here. The curved brackets are also called open, and the square brackets are also called closed. Okay, so just let's make a note somewhere over here that infinity, okay, will have open brackets. You never put square brackets around infinity because you can't really include infinity. It doesn't exist. But we can, okay, we can get there, but we will never reach it. So A is greater than and equal to would be square bracket A, infinity with a round bracket. Okay, B, anything x is less than B, so B is going to be on this side, and we're going to negative infinity. Okay, the next one going to look sort of the same, except we're going to include B. And the last one is x is in the reals. We're going to go from negative infinity to infinity. Okay, so this is just the basic rules. Now we're going to be talking about how do we use these things in calculus. Everyone's got all this? Okay, does this all make sense? It is kind of intuitive. Like once you see it, you're like, yeah, okay, it's filled in. That means it includes it. You guys always knew what filled in and not filled in meant, right? Now, just use brown brackets with. Okay? Now, here's the new stuff. Union and intersection. Now, sometimes we always have to compare two different things. They want to say, where do these intersect? Where's the union? Now, if you come just a little bit down, the union is given kind of an upwards horseshoe or a U, and that means or. Okay. And when we do inequalities and it's greater, I always think it's great or. Okay? So whenever you do greater, you're going to use union, and intersection is an upside down U, so kind of an N, but not really. And it means and. It's like, where do these share? Okay? At what points are shared? And this, when we do less than, I always think less and. Okay? So less than, we're going to use intersections. Great or, we're going to use unions, because unions mean or, intersections mean and. What do they share? Greater is, what are all the elements in the set? Okay, so here's just how, where I'm going to illustrate how this works. Okay, so here's set notation on, that's just x is greater or equal to -3, the other one's x is less than 1, the other one x is greater than 5. So what does R union S mean? Okay, well, what we do is let's draw our number line. And R goes from -3 all the way over this way. So this is all, okay, and then S is 1. So it's always nice to have a different color, but 1 would be there, and it would go like that, right? So what we're looking at is what numbers are included for R and S. No. -3 to 1 would be what they share. Okay? The graph is showing all the numbers that are included, or which numbers are in each set. And do you see that that one always goes to, that one goes all the way to -infinity, that one goes to infinity? So do you see that every number is represented by the union of those two? Okay? So this would be -infinity, comma, infinity. Okay? And that's why we're going to do intersection right beside it. Because if we draw the same graph, so I've got -3 goes this way, 1 goes this way. What do they share? Okay, so that's and, right? So what's the and of this one? What do they share? -3, comma, 1. And that's in square brackets because they're filled in, right? These should be filled in. Okay, can you see the difference between union and intersection now? Union will be, and actually even the next one helps help you understand union a bit better. I think this example is really good for intersection. People are, oh, okay, there's parts that overlap. But then that gets, the first one's a little confusing. Now let's do one that really helps illustrate the union of S and T. Okay, so we draw our number line. S is 1. And we're going to color that in, and it goes like this. Okay, so those are all the points for S. T is x is greater than 5. Oops, I want to do that in red. Okay, so what are all the numbers that are included in S union T? So we would have negative infinity, comma, 1. And we're going to put a square bracket, and then we're going to put union, five, comma, infinity. So union is said as the word or. So what numbers are included? Well, from negative infinity to 1 or 5 to infinity. Okay? That's the union. Let's do S intersection T. Here's 1. Here's 5. Okay? Where's the intersection? Where's the and? There isn't. Okay? So this would be our empty set. Okay, I've also seen you just have two brackets that look like this. Okay. So that's an empty set. There is no commonality. They don't share any points. Union is, hey, what are all the points? Intersection. What points do they share? Okay? So these two examples should sort of give you a bit of an insight now on the difference between the two. Okay? R union T. So R, got negative 3. It's going this way. Okay, and then T is greater or equal to 5, right? What are all the points that those two graphs represent? Yes, good. Negative 3, comma, infinity. Is this hard stuff? No, but it's nice to see it once, so you kind of get the gist, right? Okay, now you should almost start to figure out what's happening over here now when I've got negative 3. Goes like this. Oops, I should have done that. Okay, and then I've got, yeah, I guess I could do that right there. Then I've got 5. Goes like this. Okay. What would be the and? 5, comma, infinity. How's that look? Does that make sense? There's one little kind of caveat later that we'll see, but okay, so now we're going to solve inequalities. And just remember all the stuff we just did. But when you solve inequalities, we're often going to have to display the answer with either union or intersection or. Now, you want to move all variables to one side of the inequality, move all numbers to the other, isolate the variable, and express the answer in interval notation. Now, if you multiply both sides by a negative number, make sure you reverse the inequality. Okay, so say you had negative 4x is greater or equal to 12, and I need to divide by negative 4. X would be less than or equal to negative 3. Yep, that's exactly what this says right here. Okay. So this one here, how would I get this? We'll get everything on the left, just like you would have done in normal algebra, or in one side. It doesn't have to be the left, whatever you pick. But if I minus 8x to both sides, I'll get negative 6x. And if I add 11 to both sides, I will get, is less than 24. Divide by negative 6. X would be greater than negative 4. Okay, and I always have to finish an interval notation, so that would look like round bracket negative 4, comma, infinity. Okay? Okay, inequalities of simple squared variables. When a quadratic inequalities have no linear term, they can be much easier to solve. In fact, they can be memorized, okay? So something like this, x squared is greater or equal to negative a, has the solution, okay? Now, x squared must be what kind of number? It's got to be positive, right? So when you see something like this, you're going to see that every number will work. Now, some people go, oh, I can't do this one because I can't take the square root of negative 4, so there's no solution. But isn't everything squared greater than 4? Okay, so just a simple, basically you just have to know this, because I know some people are like, oh, I'm going to go solve this. Oh, can't do it, no solution. Okay, no, you have to actually think about it. Well, this has to be a positive number. Anything positive is greater, not equal to necessarily, but greater than negative 4, right? So this one would have the solution negative infinity, comma infinity, right? Okay, how about x squared is less than or equal to negative 4? This has no solution. So it would be empty set because nothing squared will be less than negative 4. Okay. Next. X squared greater or equal to positive a. Now this does get students really mixed up. So we do need to talk about it a bit. But this has the solution. X has to be less than or equal to negative square root of a, or x is greater than or equal to square root of a. Okay, and let's illustrate that by an example. Now x squared is greater than 4. So we could just look at like natural numbers, but 2, 3, 4, 5, 6, right? Those will work. Negative 2, negative 3, negative 4, negative 5, negative 6. So the case would be x would have to be greater or equal to the square root of 4, which is 2. And x would be less than or equal to the square root of 4, which is negative 2. Okay, so let me illustrate this on a number line. Negative 2 and 2. See, sometimes people think, well, anything greater than -2 would work. No, it wouldn't, okay? Because people get mixed up that actually -1 is greater than -2, right? And some people still get messed up with that concept. They're like, no, 1 is not greater than... No, -1 is greater than -2. Now, and how would you say this using your interval notation? You would go -infinity, comma, -2, union 2, comma, infinity. Okay, how about x squared is less than or equal to positive a? Okay, now, maybe this one would make more sense if we went to the equation. X squared is less than or equal to 4. Okay, again, we could take the square root, so x would be less than or equal to 2. Yeah, I'm allowed equal. Oh, I haven't done that part yet. I just had a question here. Okay, and then x would have to be greater or equal to -2. Okay, so I actually use this kind of example to keep things straight for me, but it is -a is less than. X has to be greater or equal to -a and less than or equal to a. Now, on your number line, here is -2, here is 2, going this way, going this way. So this is the intersection, right? So it would be -2, comma 2. Okay, so do you see how this is less than? Remember, and I said that's less and is intersection. Greater was the last one. Great or would be union, because it's or. Okay, because this is great or. So this is union. This is less than, I'm going to put less and. That's intersection. Right. When it comes to inequalities, yes. You don't use an intersection sign because there's only ever going to be one, right, run thing. And I'm going to even mess with you a bit later is sometimes there's two intersections, two sets of intersections, and then you put a union side in between. And students are like, what? They're supposed to find intersections. Why? No, because you're doing this intersection or this intersection. And the or always is union, right? You'll see. It's okay. So quadratic rational inequalities. Put everything to the one side of the inequality, factor the expression, find the endpoints or critical values, okay? So we want to know when f of x equals 0, so that's when the numerator equals 0, or when f of x is undefined, just write undefined, and that's the denominator equals 0. You do an interval test, then you test each region defined by the critical values, and then we're going to state the solution in interval notation. So we are finally starting calculus thinking here. Actually, Math 30 is quite technology based. You can use your calculator for a lot of stuff. This, you're going to actually have to depend on gathering a bunch of evidence by knowing how to do a bunch of different things and then coming up with an answer. Okay? So, let's do one. Okay, so how do you solve when x squared is less than 7x? Well, if you look at step 1, it says put everything on one side. Okay? So that would be x squared minus 7x is less than 0. So this is actually my inequality. When is this thing less than 0? Now, if this was a 30-1, we could graph it. Well, actually, it's grade 11, 20-1. You can graph it, and whatever part of the graph is under the x-axis, that's less than 0. So what x's give us that, okay? But we're going to have to do ours without the calculator. So we want to factor this, and when we factor it, we will take out an x, and that will leave me with x minus 7 is less than 0. Now, our critical values, you're going to hear this word a lot. Critical values are when this thing is either undefined or when it equals 0. So what values make this equal 0? Yeah. Are 0 and 7. Okay? Those are where this graph changes. Okay? So what you want to do, you want to go on your number line, and you're going to put the values 0 and 7. See, I want to know, when is this graph less than 0? When is this equation less than 0? And you do some of these in grade 11, but we're going to start using test values. See, I want to test here. I want to test between here and here. And I want to test between here and here. So what is a good value to test in here? -1. You kind of want to be nice to yourself. So I kind of write it in brackets so I remember. And we're actually going to put it into this equation. It does make it easier when you put it in this equation. So if I put a -1 in here, I will get a negative, right? Obviously. Or we don't need to. Okay, if I put a -1 in here, positive or negative? -1 minus 7 is what? Negative. So this would be a negative times a negative, which equals a positive. Okay? Next one. What's a test value get in here? 1. Okay? So just so you don't forget, I'm just going to put my positive 1 there. Okay? So that is a positive times a negative. So a positive times a negative, which equals a negative. Okay, something greater than 7, 8. So a positive, right, times a positive. Is a So does everybody see that using my test values I've answered the question? It says, when is this less than 0? Does everybody know another word for less than 0? Negative. It's asking, when is this negative? Nope. Yep. No. I have found using my critical values and then test values, when is this less than 0? It is less than 0 between 0 and 7. Okay? Actually, what the problem would look like this. Oops. So you can see that is when the graph is below the x-axis, right? And that's why you don't get to use a graphing calculator, because some people could skip a lot of hurt and just put this into the graphing calculator, and there it is, right? And this course is all about pain and discomfort. So you do not get to use your graphing calculator. So here's my highlighter. Here's our answer. Okay? So how would I explain this answer? This is between, now, do you see, here's something really, do you see how they use less than here? Not less than, equal to. Okay? So you make sure that you're going to be using this here. Oops. So we're going to do x is less than 7 and greater than 0, right? Or better, 0, 7. Okay, so we did all the steps. Now there's a chart way to do these, and they are a lot of work. They take a lot of time. They're a lot of work, and they take a lot of time. Okay? This keeps things simple. You're not drawing a big chart. You're not putting a bunch of stuff in, and keep it simple. Less chance of making mistakes, and it kind of makes sense. If you understand number lines, it helps. Okay, let's see this one. X squared plus x is greater than x plus 6. Okay, what was always the first thing we need to do? On one side. So x squared minus x minus 6 has to be greater than 0. Okay, so we're going to look on our graph when this is going to make positive values. Okay, we can factor this one, equals -1, multiplied gives me -6. X minus 3, x plus 2 is greater than 0. Okay, so what are my critical values? 3 and -2. Okay, so let's go right to our number line. Okay, -2 would be there, and 3 would be there. So now I want to go just to my number line, and I want to test some points. So less than -2, what's a good point? -3. Now you want to plug -3 in here and here. So if I plug -3 in here, that is a negative. If I plug -3 in here, negative. So that's a negative times a negative. So that is going to give me a positive. So I always circle it and put it on top. Between -2 and 3, again, be nice to yourself, use 0. So that would give me, 0 minus 3 would give me a negative here, would give me a positive there. So that will give me a negative. Okay, why don't we pick 4 for our test value for anything greater than 3. 4 minus 3 gives me a positive. 4 plus 2 gives me a positive. So that gives me a positive. So I am looking for when is this thing greater than 0. So here and here are my answers, correct? Now, this is a great OR. Okay, great OR is union. Okay, so this is like, give me all the values. Do I ask for the values that are shared? No, I ask for all the values. So it would be from negative infinity to negative 2. Square or round bracket by the 2. Negative 2. Round. Or, so union 3, comma, infinity. So we did some of this in grade 11. You may not remember, but we did. Okay, one more example. Okay, so this one, a little bit more difficult than the other two. But hopefully we got a good foundation. Now we can make the question a little harder, but not have to try and understand how the number line works and interval testing and all that stuff. Okay, so this one here, how do we get everything on the left? Algebraically, what should I do? Multiply by x minus 5, but that wouldn't get everything on the left, or on the one side. Minus 3x, right? If I divided by 3x, would that help? If I did, what would be left on this side? 1. That's not getting everything, right? We want to get everything. So don't divide. You're going to have to subtract. So that's 2x squared plus x over x minus 5 minus 3x has to be less than or equal to 0. So we're doing a less and, right? So we are doing intersection. So, what's wrong, Joanna? Nothing? Okay, so first thing we got to do, common denominator, right? So a common denominator, 2x squared plus x over x minus 5 minus 3x times x minus 5 over x minus 5. Oops, less than equal to. Okay. Now since they're both over a common denominator, I can actually, this would be 2x squared plus x minus 3x squared plus 15x all over x minus 5. I just brought the negative 3x in, okay? So I got 2x minus 3, or 2x squared minus 3x squared is negative x squared plus 16x all over x minus 5. And this has to be less than or equal to 0. Okay, I can factor the top yet to take out an x or a negative x, whatever. I'm going to take out a negative x. That'll leave me with x minus 16 all over x minus 5. No, I didn't divide by negative x. I actually just factored on the one side. It's a good question. Yeah. Yep. Well, if I took out the negative, because 16x isn't a perfect square, right? Okay. So, critical values. 0. So far, so good. 16. and 5. Remember, all the times it makes it 0 or undefined are called critical values. Okay, so let's do a number line here. So we've got 0 is going to be on here, 5 is going to be on here, and 16 is going to be on here. Now, this is kind of foreshadowing a bit, but I always like to do this as well on negative 5, because on 5, not negative 5, because that is an asymptote. And you guys have done enough with that stuff, so you know. So, because later we're going to be drawing graphs just from interval notation and stuff like that. So I want to make sure I've included that on the actual graph that I want to draw. Okay, so let's do our intervals. So let's do less than 0. What's a good number? Negative 1. Okay, now be very careful here, because there's 3 places to put the negative 1. So if I put it there, that will be a positive. If I put it here, negative. And if I put it here, negative. Okay, so this is what this looks like. Positive times a negative all over, what did we say? A negative? Yep. And that would give me a positive. Does that make sense? Okay. What's a good test for between 0 and 5? 1. You guys obviously don't like a challenge. Okay. What if I put it in? So we go back to our equation, guys. If I put it here, what do I get? Negative here, negative here. 3 negatives, right? So that is a negative, negative over a negative. Okay, negative divided by negative is, negative times a negative up top is positive, divided by negative is big negative. Okay, keep going right between 5 and 16. 6. Okay, and you often will not see these on a, okay, but I always put them there because when I want to check my work over, I want to, like, what did I do, right? I'm not a very good memory, so I write that stuff down. Okay, if I put a 6 in here, that would be negative. How about here? Negative, positive, right? So negative, negative, positive, which would give me a big positive. Nope, don't know, because then we get into x cubed next to the 5. No. Okay. Okay, not that this is a great number to work with, but let's face it, we're not trying to do the math. We're just trying to get the sign, so it's not like it's slow, okay? So we got, this would be a what? Negative, this would be, and that would be, so we got a negative, positive, positive, which would be a negative. So highlighters are pretty nice to have on these exams. Actually, when you're doing a whole page of stuff and you're doing this graph and everything, it is nice to actually have a bunch of different colored pencils or something. Keep you organized. So I am looking for when this is less than 0. I'm looking for the negative, right? The less than. Okay. So when is it less than? Now, am I using square or round? So 0, comma, 5. Should I do a square here? Is it allowed to equal 5? So use round for asymptotes, right? And that's probably the best reason to draw an asymptote at that point, because we know that 5s are non-permissible. I should not be using a square bracket. Or union 16, comma, infinity. And again, use a round bracket with infinity. Yeah, you always have to go in the order they fall in the number line. Okay, how's this? Yep. Yeah, see, the problem with multiplying by x minus 5 is that if this was, say 5 is one of the solutions, then you have multiplied both sides by something that might not even exist. So if you bring it all, that is an excellent point. Why use addition subtraction to get everything on one side? Yes. Yeah. Yeah. There's a few I could confuse you a bit more and give you some examples of why it messes up, but yeah, just trust me. You don't need it. Okay. I make a lot of stuff up, so I thought, well, maybe I should show them, but I like that. Okay, so we're doing 1, A, C, D, H, I, K, L, M, N, O, P, Q. I think I left out J and B. See? Okay. How's that? Okay. You got 20 minutes. Let's get lots done.